What we're going to try and do is take you through the bean counter set. That's a set was reduced down to nothing so they could sell it cheap. What we're going to find out in the beginning, we communicated without vacuum tubes across the Atlantic, spark. How did they receive these signals? Tuned circuits. Circuits that had resonance. We're going to go through this and show you where the resonance is at and why this set was developed. Armstrong and a couple guys at the end of World War I came through and came up with a superheterodyne circuit. Why they called it super was probably in the beginning, but heterodyning in terms of analog radio is a mixing of two signals together. This is if you were on an organ and you hit one key, hit another key, you come up with a different tone. Okay? Now what they found out with a tuned circuit, if you had a 3-dialer set, you had to go in and tweak just like a bank safe. You try to tweak up these analog circuits, these tuned circuits. The problem was there was only an optimum place where the gain would be maximum. The tubes were lousy, 01As. You couldn't push the tube too hard because it would break into oscillation. So they come out with a Newhardyne. Now, the other problem we had, we're always going to refer back to New York City. This was the mecca of the world at the time. Not only people lived there, millions of people passed through there. Okay, so they developed the superheterodyne in the late 30s. I mean, not the late 30s, the early 30s. Philco never had a license for a superheterodyne until 31. They still made a TRF set. Okay, so anyway, what they did up in New York, 20 stations within 10 miles. They made the cheapest radios that God could ever make, with the worst crap there was. Beautiful cabinets. You go in the store one week and say, oh, that's a beautiful little cabinet. Go in the store next week, look at that cabinet. It's the same chassis. Emerson was famous for that. Okay, so they come along and they say, you know what, we can't solve this problem in New York because half of New York is DC. Well, these engineers were brilliant. They came up with a tube that would work on AC and DC. They series strung it. Because number one, if you lived in New York and you lived on the 51st floor, you're not going to carry a console up there because almost all the superheads were consoles with big legs. Plus you had a 2 rooms with a Murphy bed. You had no place to put it. And if you did get it up there and you turned it on, the neighbor would be pounding on the wall. It's too loud. They decided to reduce this down. So in the early 30s, they came up with series tubes with high voltage, 50 volts, 42 volts, maybe 2 12-volters. And then they slipped this Mickey Mouse in there. This is called the curtain burner. Here's how they drop the difference in line voltage. On these, you'll see there's 3 leads. One was a tap for a pilot light. The other 2 would try and drop the resistance that was needed for the series string. They were curtain burners, and if you have one with an old cord like this and you turn it on and run it, you feel that baby, you'll know it's true. But anyway, it's a sample of what that was. So finally, they come out with better tubes. Now, if you're going to make a small set, you don't need a big power transformer, you don't need a big thing. You have these series tubes, and these particular tubes were actually invented to work on low voltage. But actually, when you look at that circuit, that's not really a 5-tube set. If you look at the functions on there, it's a 7-tube set. The first tube is a pentagrid converter. That tube up there has 2 circuits inside of it. One is an oscillator, and the other is actually a mixer that comes in with the incoming signal. The other tube up there, the V3, okay, that tube has 2 functions. You see the 2 little bars on the left? That's the detector. That's right in here on V3, these 2 little plates. This is a triode. This is a voltage amplifier. This is the power amplifier in the set. And with this power supply, 80% of the power is going into this tube right here. This is the thing that's drawing all the current. Now, if we only have one tube in the output, we don't need much power. We don't need much at all. You guys buy a Zenith, 12 tuber. It's the same circuit, but there's 5 tubes in the audio. You need a power supply, you need high voltage, you need everything to try and drive this 14-inch speaker. But basically this circuitry is the same. It has not changed in almost 100 years. The only thing changed was the bean counters. They come in there and say, how can we make it cheaper? Well, in this case, you have a very small speaker, 4-inch, you'd eat much. You could put it on your nightstand. You can carry it underneath your arm. Okay? And the beauty of this set, it'll work on 110, 115, or 125. You don't have to do a damn thing to it. The tubes can take it because they're all in series. Okay, we're going to go back and we're going to say we have a sheet out there called a block diagram. I don't know if he handed those out. Now, I'm not a draftsman. I sketched that up quick. The importance of that block diagram is this. Whenever you work on electronics, a block is a circuit. And that circuit has a certain function that it has to do. So you can take anything. It doesn't have to be a radio. Break it down into pieces and sections. And what you do, most people, they find an old radio, they put a set of filter caps in it. That's it, I quit. That's where it's at. Well, let me tell you something. The earlier sets from the 30s, a lot of them didn't have a permanent magnet speaker. They had a field coil speaker in there. When there's a field coil speaker in there, this is called a constant current supply. Because the cap discharges, the coil's dumping it back into the cap and trying to keep the cap from discharging. They found out they'd get away with that. Put a PM speaker in there. The difference is you'll find the values of these caps right up there will be different if you have a field coil speaker. So in other words, what we're saying is, if you look at the print, look at the capacity of these, what you're going to know is that they're not going to be the same as one that has a PM speaker. They'll probably be less. Your Simpson, the biggest selling meter in the world. It has outsold everything. This is a fabulous instrument. If you can get your hands on one of these, you got a home run. But if you see one at Kutztown, and the reason I brought a lot of this stuff along is this is what you should be looking for, because you can find the pieces for peanuts. Carry some resistors with you. 10 ohms, 1,000 ohms, 100K, a mega ohm. Check it out. You'll find a lot of them that are damaged. Okay? Now, this has a couple functions on that are very unique. When you're looking at these filters, if you have a set with a bad filter on it, you can look at this output cap over here. You go to AC output, you can see the ripple. The problem is that the first cap will have ripple on it. The second one should have nothing, or very, very down to nothing. Maybe a volt peak is all you're going to see with this. Last time we talked, we told you how to check batteries. Batteries are current devices. They're not voltage devices. The example would be if you had a battery in your car and you want to know it was any good, what did the guy do? Put a load across it. How much current it can put out. Same thing with a battery. Even one of these batteries here that's new, a AA, on the 10 amp scale, will drive this up to 1 or 2 amperes. A D cell that's fresh will be 5 amps. And you can check it on here, but you have to use the jacks that are marked in the -10 and the +10. That's the upper jacks. You don't want to put it in the lower ones because you'll probably blow a fuse or whatever you want to do. There's a couple features on here that are very nice. Now this meter is a known impedance meter. This is 20,000 ohms per volt or a 50 microamp meter movement. This meter didn't come on the market in probably, excuse me, 38, 39. Prior to that, if you were working on the radio from the 30s, the mid-30s, you start looking at that print and you're going to see these voltages, and you're going to go in there with that Simpson and say, oh man, this is really high. Well, when you take a reading with a meter, you're in parallel with that circuit. It's like taking two resistors of the same value and cutting it in half. Those meters are 1 millimeters. The reason I say the red pointer on a Simpson, Series 5 or above, it has a taut band suspension. It's a different movement, and it can take a shock. You take one with an older one with a black one and you make a mistake, you might have a question mark instead of a needle, and you're in trouble. But anyway, keep your eyes out for these, and if you do find one, if the guy says it's good, look in the battery box. And anything you buy that has batteries in, you open up that battery box, because some of this stuff will be rotted or shot and beyond repair. Okay, let's get through that. Let's go back to the sheet I have on here. This is the one about test equipment. I know I'm hopping around here, but this is the way it goes. The Simpson 260 is the 5 with the red pointer. It's 20,000 ohms per volt. My partner here was supposed to bring in an ME9 meter. It's an ugly looking military meter, but the beauty about it has 1,000 ohms on it. So you'll get the exact reading. And in fact, if you're trying to repair a Hickok tube checker, you can only use 1,000 ohm per volt meter. You'll be in there trying to set 150, it's reading 225. What the hell's wrong in here? You have to load the circuit. Okay. Digital meters. Not for these radios. You save that for your transistors, whatever you want. We do not know what the impedance of that meter is. If you have a print, a lot of times you'll see on the bottom, readings taken with 20,000 ohm per volt. Readings taken with 1 megohm per volt. Probably one of the finest meters ever made. The V7A by RCA. You might not need this to fix a superhet, but there is times when you can look in a circuit that any meter will disrupt the voltage you're trying to read. A good place would be the negative voltage that's on this grid converter. You can see it. You can also see the voltage on the AVC line, which will go through. All right, signal generators. You recappers, the guy wants to recap every damn thing. The first thing you do when you're working on your radio, you get this power supply working. You make sure this is right. I have an indication on here about this lamp, 47 pilot lamp. This particular tube is a half wave rectifier. In other words, it has a half and a half. The cap is large enough that it can drain across before it discharges till it gets the next cycle, all right? If you come down here, this tube, every tube in this circuit, 150 milliamps per tube, series strung. There's a tap in this thing. There's a tap in there for a 47 pilot light, which is 150 milliamps. Number 47. That's what belongs in all these. You see this tube complement? That's what goes in there. Okay, so we go beyond that. We have a small resistor here. This isolates this, okay? So the next thing after you do this, what you're going to do is you're going to go up to the output tube. This is where all the power is basically being consumed. This stuff here is drawn dribbles and drabbles. That's about it. Okay? So you go through this circuit. This is usually a pentode. It can be a beam power, whatever. And the other thing which I want to bring out is this. You're a fool if you don't have one. It's not only what's into there, the information, the correct operating voltages and stuff like that, but there's also a lot of theory of tube in the front end. how a pentode works, a tetrode, a triode, and what the limitations are. Now, when it comes to tubes, there's no magic tubes. There's good and there's bad. I tell people that want to work on this stuff, you get a series of set of tubes. You mark them test and keep them on the shelf. Because every once in a while you're going to get snookered by a tube that it's not going to show up on a tube checker. Because the tube checker is checking at 60 cycles. That tube is running at a megacycle or 456 kc or 455. There's internal capacitance. You want tubes, you buy them from that man over there at the club. He's got the finest tube checker you can get. That instrument is enormous. It tests the tube at 450 volts if it's rated at 450 volts. The tubes you're going to get from him are really good. Use the junk tubes. Okay, so we go into this circuit here. This circuit shows a resistor here, R6, if you have your prints there. What this resistor does in this little cap, very low voltage, is keeps this cathode constant. In other words, this tube is going up and down as this signal is going across, and it's surging up and down. This is holding this cathode constant. Okay? Now you go up here. You see this C6? Don't even put filters in unless you replace that baby. That baby is always bad. And that cap leaks. It gets a couple, remember what a cap does. You put DC on one side, the other side is AC. It's only the signal. You put a couple DC volts on this tube, it's like taking your car and putting it in neutral and tramping it. That's about what it amounts to. Okay? A lot of times this tube can be damaged. It'll test all right in a tube checker, but maybe you're playing it for 20 minutes and all of a sudden it starts to distort. It's got grid emission or it's probably gassy. You can use a 50L6, 35L6, I have the numbers on there. The other thing is this C8. That bypasses the highs around the output transformer. In most cases, these output transformers, they say 3,000 ohms. You look on the print and say, isn't it 3,000? That's impedance. That's AC resistance. When you check that with your meter, you'll find out maybe it's 200 ohms. It's okay. As long as you have plate voltage up there, you know it's all right. Miniature PM speakers, nobody will recount them. And believe me, for a 4 or 5 inch speaker, there must be 1,000 different ways to mount one. So you got to be very, some will have transformers bolting the top, screws in the side. You can't drill through that stuff. You just have to look for another one. Okay, this is the RC component that develops the audio signal. This R5, on a table set, it's almost 470K. And when it comes to resistors, most of these radios, 10%, 15%. That's fine. Stay with the old carbons. There's a reason for that, because some of the newer resistors, when you get much more sophisticated, you go up to higher frequencies, they become chokes. They're not made the way a carbon resistor is. You'll have trouble up in the shortwave band with some of them. They're real tiny, and they're machine done. I don't know how the hell they're done, but I've been warned about them. Okay. This is the voltage amplifier, V3. That tube gets chucked a lot, and I don't know why. The little diodes on there, they say, oh, the diodes are weak. The reason they're using a vacuum tube diode is because the breakdown is a lot lower than it would be if you used a crystal. You don't need hardly any diode detection on that. This is what's taking the signal that's going through this radio and picking off the audio, or the voice that you hear. That's a modulated signal that's going through there. You've got your carrier. And on that carrier, what you're seeing is you're seeing the modulation on top. Now, one of the mistakes a lot of guys make, if they're trying to align a radio, they try to align to a radio station. That's a no-no. That radio station, especially if it's strong, will drive this diode detection back through this AVC line, it'll cut off the gain on the front end. That's automatic volume control. You actually desensitize the radio. That's what you've done. So this circuit, if you want to go into an alignment, we're going to go through an alignment, you want to run the weakest signal that you can possibly detect with that guy. In other words, you could put 400 cycles through or 1,000. And what you really next want to do is go to the heart. Oh, by the way, let's finish up here. These resistors in here are going to be very high in megohm value. And believe me, when resistors go bad, they usually go high. This would be like R7, what does it say, 4.7, 3.3 megs. What is R5? 220K. Okay, this is a triode voltage amplifier we said fed into there. This is where the signal is developed through C5. That goes to tone control. Now if you go through this circuitry, after you change your filters, get this crap out. Make sure it's good, all right? And then what you want to do, if you have that done right, you fire it up, use your variac, your isolation transformer, guys. I'm telling you about that. You don't use an isolation transformer, you're causing yourself some trouble. These sets have hot chassis on them. And you know what? They didn't have polarized plugs. So you can touch this, and you can touch your instrument that you're using. In fact, you could take your meter and go across the instrument and go there. Hey, I have 120 volts between the two. Well, guess what? If nothing else, you can blow up your test equipment. That's the reason you want an isolation transformer. You get to a power transformer, it's isolated between the magnetic field. Okay? So we go through this. Now, this is the heart of the radio. T2 and T3. It's the Q of these coils, the quality of the coils. There's cheap ones, there's intermediate ones, and there's some that are very, very good. Now, if you get a high-performance IF can, these are called the IF cans, right? The secret in this is all four of these stages have to be peaked at exactly the same frequency. If this says 456, this has got to be 456, this has got to be 456, and that's got to be 456. Every one of them. The quality of these coils really, really determine a lot. If you notice, you'll see some of the sets will also have AVC. Do you see this AVC line coming over? R7? It's part of the AVC line, which is picked off from this detector. Down here, C4, what that is, that's a small filter to remove the carrier that's out there. There's still carrier going along. Because it's such a high frequency, that's a very small cap. Very seldom ever gives you a problem. 200 puffs is usually what it is. This indicates this is in a shielded case. We know that. Now I'm going to show you something here. This is a can, a new one. This is from my mid-30s up till right after World War II. These cans are excellent. They don't give you hardly any trouble whatsoever. But there's one thing to note about these. You have sets where people go in here to adjust these with a metal screwdriver. No, no, no. You won't only detune it, but what you will do, there's a possibility that if you short it to the case, you burn out the winding because the case is on ground. The blue lead is the plate lead, the red lead is the B+ lead, the green is the grid for the following stage, and the black is the common. Now, the ultimate of the bean counters is this guy, a K-Tran. It was a patented device that was made that, believe me, will drive you up the wall. You got a set working? Up, down, intermittent, crashing, this, that, whatever. Because these cans are tied together, there's a common to these. It's difficult to locate which one it is. But you're definitely going to find it's usually the first one. Now, my partner here, he screwed around with these things and he was able to take them apart. There's a rivet in the bottom, and what they have inside is a little piece of silver oxide. Squished between two plates. Well, we know silver tarnishes. They get into dampness or something like that, they're internally arcing. So there's no way you can tune this circuit. This circuit that we're looking at here is a parallel resonance circuit. We come in here, this is set at 455. And we'll show you how we get that. And what happens is you come across here, you set this 455. When you get to 455, this tank circuit, this parallel resonance circuit, this coil and this cap, they create a very, very high impedance at one frequency. It doesn't have to be 455. But if it's 435 and this one is 455, no way. You're going to be down on gain. This is where all the gain of the superhead is, really in here. You can have a preamp out there, an extra tube. All that does is probably keep both stations from being on top of each other. But anyway, the shape of this is really important. I think some of the sheets I put out there, you'll look and you'll see a graph on the bottom. You'll see the one on the left. That's called the bandpass of an IF transformer. Okay? Now what you'll see is the first one, you'll see it's a little broader. But as this coil gets into a high impedance state, there's a constant current changing back and forth, coil cap, coil cap, coil cap. And at one frequency, it doesn't want to let anything else in. It doesn't want to let another frequency in. It's going to go optimum, maximum AC impedance, Z, at the frequency that that's adjusted to. And you can adjust it. Now, because this gets so big, it transfers the energy to the next coil. Okay? Now it's stronger. Now you put an amplifier behind it, and it gets even stronger again. But the most important thing about this, I'm sorry on the way I'm mixing this up because I'm going between test equipment and all this other stuff, is number one, you take that little Simpson you have, you clip it across the voice coil of that speaker. You take a generator, put in 455. Usually they'll tell you where to put it, but actually you can put any one of these grids. If you got an outside, go to a quiet spot on the station and just bring up your generator enough to see that needle move. That's all you want. And the reason you want to keep it low is because if you do not, AVC will cut it off. It'll tone it down. It'll try and shut the radio down. So actually, this is going to be your indicator. You can use a scope if you want, if you have a scope and just want to play with it. But anyway, you inject your 455 or 456. And by the way, older radios don't have to be 455. They can be 370. Philco used 470. There was all different kind of frequencies that were used, but they all have to be identical in that particular circuit. So anyway, you come along and you start with the last can. That's the last can. There will be 2 cans in there. A real exotic radio might have 3 of them. Then you really got a home run. But anyway, this guy, you start with the last one. And you work that thing back and forth. And by the way, don't use a metal screwdriver. Okay, so you pick that up. Go to the next one. Do the same thing. As the signal's starting to get stronger, you'll start hearing the ether coming up. Back the generator down. Keep it at the lowest level. Go to this guy. And when you go to this guy, you're going to see the gain come up. Now here's the thing about this. These trimmers are always out from age. So you go in and you recap this radio. You're creating yourself sometimes a lot of problems. Remember what I told you. Fix the power supply. Fix the audio. Put your finger on the arm of the audio volume control. You'll hear it in the speaker. If you have 400 cycles, you can put it in there. Now you know this is working. This is where all the current's at. Now your next step is to go through here. Okay? Put your signal generator. I have on this instrument paper, there's some suggestions there for instruments. Now, if we go to this IF amplifier, you'll see a couple parts in here. This 180 ohm resistor in here, you won't find this too often. What this resistor will do is cut back the gain of the IF. And the only reason I know that they might do that is because if it's a lousy radio and the gain is too high, it might break into oscillation. You don't see that too often. Okay. This is the filter, C4, that you have on your print. That's taking that carrier down to ground. Okay, now we're almost home. We're almost through this. Now we look at this. We have the pentagrid converter. T1 is called a Hartley oscillator. In HF ranges, that's the one that's used the most. And in Emerson, you'll find one with 3 windings on it. I don't know how the hell they ever did it, but capacity coupling or something. It was a cheaper way to make it. And what we're finding here, you got a signal coming in. You tune your radio station to 1000 on the dial. That's 1 megahertz. Okay? Now, this oscillator is going to run 455 kc above. So when these signals mix, this signal up here and this signal on this grid, you're going to get 4 frequencies in there. Some in the difference, but one of the frequencies will be the 456. No matter what station that you tune to, this will all be 456 kc above. If you're in a shortwave band, it'll still be 456 above. That's how they were able to get the gain. If you have a tuned circuit, it has a resonant point. Once you tune that circuit and go off a little bit, it doesn't have that high impedance anymore. Okay? Does everybody understand about what I'm talking about, a tuned circuit? Okay. All right, I call this the bean counter set because number one, they couldn't sell radios up in New York because of the size of it. So they start dumbing this down. These guys are brilliant. They really did. They solved the AC/DC problem. They solved all this other stuff that was out there. And they made a set that anybody could carry or whatever. A Catalan. $25. That's what they cost new. Yeah, that's right. You had a case. You had a beautiful case. Emerson, oh, Ingram Cabby, isn't that gorgeous? You look inside, what the hell, there's nothing in here. There's no magic tubes. Remember that. There is no magic tubes. There's tubes that are defective, and again I said, you talk to this man over here because the equipment he has, we'd kill for. It tests a tube at the correct parameters. There's very tube checkers that will. There's a lot of them out there, and a lot of them are emission checkers. And what an emission checker does, it counts the electrons going from the cathode to the plate. That's not a measure how a tube amplifies. You put a signal on a grid, a small signal, and you look for the change in plate current. That's an emission checker. Now, it'll bring out shorts. That's one thing. It'll tell you if the filament's good. And emission test, 60 cycles. You're at 1 megahertz. So that's the whole thing in a nutshell. Don't be afraid to buy bags of junk tubes or stuff like that. You'll find some good ones in there. But I would say on your bench, keep the ones, the common ones. Keep them, mark the box, test only. You'll be in there trying to pull your hair out and say, I don't know what the hell's wrong with this. And you put first tube and the goddamn thing works. I mean, that's crazy, but it's happened to me. It's happened to all of us. Okay, there's a couple other things. There's pretty much on this. If Jim Amici was here, he'd call this the bread cutters. That's those 2 tuners in the front. They're synced together, but they have a different capacity, and that's how they can get the one to run higher than the other. There's 2 adjustments on there. Okay, after you've done your IF, And baby, when you do this, you're going to hear it right away. You're going to hear this white noise come up. I never heard that before. It was really quiet. Well, it's not anymore. I can hear things. So anyway, after you've done that, usually with a superhead of this type, what happens is this pentagrid converter has a tendency as you go lower in frequency. And if you look at this, you go down to the low end of the band, 550, all right? Well, the plates are all closed. If you look at with your V7A, and you'll see now the injection voltage, which is right up here, the first grid. You'll look at that, of course, there's hardly anything there. Well, guess what? They tell you to tweak it at 1400. Almost all your radios, you set the upper end. This is the first adjustment at 1400, okay? And the best way to do it, I don't care what they tell you. If you got a small radio, take a loop of wire, hook it up to your generator, put it close to the radio. It's as if it was coming through the air. You can clip leads on doing stuff inside, but in some cases, you either have to put a capacitor there, you have to know what it is. Sometimes you have to follow what they tell you, but you'll set this at 1400 and you'll find the injection voltage up there. That's going to be real high, 8 or 9 volts, negative. When you get down here, it's practically 2. So what the circuit they added is called a padder. When you're looking on your print, it says pad at 600. Go back, set 1400. Go back at 600. And every time you make that adjustment between the two, you're going to find out that that padder is adding capacity because those plates are already closed. So we're adjusting that for the 600. Now it doesn't have to be 600. It has to be the loudest signal you can get around 600. They always say rotate the dial. That's where I'm getting the most signal. Okay? Now you go up to 1400. Now you got to reset that again. So a lot of sets, and probably one of the worst ones you ever work on, if you get, what I'm trying to do is tell you this about this set, because number one, if you can understand this, you can work on any damn set that was ever made. There's some difficulties you'll run into. One of the worst sets that we work on, but we like them, but they're shit. Excuse me, can you remove that from that? This is probably a Zenith. Beautiful cabinets, great audio, lousy circuitry, rubber wire. They are a pain in the butt. High impedance IF cans, there's all kinds of stuff. And another thing on some of these sets, those can domes. Those are bad news. A lot of times they're bad, they're intermittent. If you try to bypass them, sometimes they'll reconnect, you know, whatever. But the good thing, pardon? What's that?
You're going to bypass and use wire round.
Yes, yes.
Not carbon resistant.
You don't, you know, you can't. The power isn't there, you can't do it. You have to dissipate. Notice the can dome never has any wattage on it?
Put a 5-watt carbon resistor.
Well, it depends which circuit you're working on.
That induction is part of your, normally part of your power supply.
Well, the whole thing about, here's two things I could say about a Zenith and a Philco and an RCA. They all had good power transformers. They did. If you go down to something like an RCA, I mean an Atwater Kent, oh, forget it. You better run that thing at 95 volts or something, or you're going to kiss that one goodbye. The other thing I want to say is Zenith used a lot of rubber wire. And got to be careful.
RCA too.
Tubing. Tubing. But what I'm going to try and tell you, if you really want to get into this, what you should do is you go to Kutztown. Don't look for the prettiest radio you can find. I always say get a decent cabinet. I look and I see some plastic wire, I just walk away from it. I mean, somebody was in there hamming this thing up, you know. But anyway, a rotten line cord, that's good. That's good. When you see that, nobody's been in there, you know. Never plug and set in. without a variac on it. I don't care what kind it is. Bring it up slow. When you're working on this set down here and you're troubleshooting, okay, go for the pilot light. See if the pilot light's good. Put it in there, bring it up low. See the pilot light? Tells you the string is good.
Well, was there a time that they worked on radios, they didn't have variacs? I mean,
Well, most of the radios at that time, believe it or not, had power transformers in them. They were the big, heavy things, you know what I mean? It's when they dumbed these things down. Okay? Now, suppose this doesn't work. Use the magic sauce. Spray that sucker. WD-40. Keep clicking it back and forth. All of a sudden you have continuity. Dirty contacts. Also, the volume control in all these sets, R2, 500K. It's the most common standard control there is. If you got a real bad one, you could pick up any junker and just grab it. Just make sure the shaft fits. WD-40 on there is fabulous. You use solvent. Some of the cleaners are solvent. Look at the carbon element. It's got granules on it from being rubbed back and forth. It's like dirt inside. That WD-40 will lubricate that control where the solvent will evaporate and dry out. If you're working on something with high voltage switches, clean the switches with alcohol. The reason for that is because on the high voltage sets, 250 volts, 320 volts on a plate, you change bands, you're switching B+. You will see a laser beam come out of those things depending what you put on there. And if you see that, the only thing you can do is either get a Dremel or get it out or try to change the wafer. I don't know how I got off into the high voltage sets, but anyway, the difference between this and the earlier sets was these tubes were dumbed down to work at lower voltages. The highest voltage in here, B+, is probably 85 volts or 90 volts. The highest voltage is going to be on the screen. The screen is the accelerator. That's what made tubes work. When they come out with a screen grid tube, that's where they kicked butt. First it was a tetrode, and so on. Then they come out with a 35. That was a remote control tube, where you come up and get automatic volume control. Okay, what else do we have in here? We have that list of test equipment. Okay, now you guys that don't want to solder a lot, or haven't soldered a lot, let me give you a couple pointers here. Some guys are meticulous at soldering, and some guys are slobs. And you can really make a mess out of something. The first thing I want you to see, where the heck is it? Here. You see this solder? Pass it around. Do you know what that's good for? Copper pipes.
Plumbing.
That's exactly right. You put that on, you got goobers all over the goddamn place. This is what you want. 32 thousandths, real fine. Now I'm telling you this, when you go in there, you start recapping. Okay, these caps that we use and we sell, these caps are marvelous. These little yellow things. And we also have here, which I want to talk about, this is something that Stan Siger made up for us years ago, our long past president, which actually passed this year. I'd like to have the club to remake these. This breaks all the codes down, how to read the micas, different size of resistors over the years, how they're done, the pilot light data. There's a lot on here. Okay. All right, now let's go down here. These caps are fabulous. These little yellow caps, I have a $3,000 cap checker made by Sencor, one of the best ones they ever made. If I put a 473 in there, that's actually a .047. It reads .047. You can calibrate any cap checker you have with these. No matter those mechanical dials you're looking at, they could be off a little bit, you know, from age. That's it. But you can go in there and you can say, oh, this is supposed to be a .047. If you have a .1, you go in there and you can actually see where the error is. And remember something, fellas. You can find test equipment for peanuts. But it does have a power supply. If you could put filters in this, why can't you check the filters in your instruments? Think about it. Everything has a power supply, no matter what you work on. Okay, some more handy tools. You can work from above. That's every socket with pinouts on it. You plug it in, put the tube in, you could test from above. This is a military kit. And by the way, if you find anything in gray, take a good look at it. You guys paid a lot of money for it, tax money. And that stuff is good. Now, the reason I'm telling you this and some of these things about test equipment, don't buy anything that you cannot get a manual for. What do we say? A signal generator. Heathkit, ICO, Knight, small. They are so simple, a kid could put it together, but it also tells you how to calibrate it. You buy something else, forget about it. All you need is equipment that was generated between the 30s, 40s, and 50s. That's it. You could fix any damn thing with it. All right. Solder sucker. Here's a couple other goodies here. We told you about these cans. You get the intermittence, look on the side for the 119. That is a manufacturing code. The other number you'll never ever decode. My partner here spent a lot of time with this stuff. Actually going inside and putting actually the fixed value inside to replace that silver washer.
Bigger one's not gonna work.
Well, he did it.
Those you put underneath.
Okay, you can put them underneath. He's correct. This cap, the Sprague, that's a resistor. That's not a cap. If you want to check your meter, check this for ohms. These are bad. They were bad from the encapsulation. We call these little tigers, we call them bumblebees or whatever they are. They gotta go. I don't care what the hell you're working on, they gotta go. In fact, the only place they used these in the end, which is amazing, was off the power line. And a lot of times you'll open up the radio and it's still playing, and there's that cap, it's just split in half.
Yeah.
It explodes. You know, so. Okay, we got that. Let's see. Marvelous instrument. Very good instrument. The Simpson will read the leakage on caps up to 20 megohms. Any cap that you look at, and by the way, when you're changing these caps, these wax jobs, all that stuff, they're bad. They're not only leaky. What happens to these caps is they change value. They go up. And what happens, you'll say, in this circuit here, C6, this really important part here, this is supposed to be a 005, okay? Well, if that goes up to 02, you're going to blow that speaker apart. The bigger this cap is, the more bass you're going to get. And these little speakers can't handle it. And by the way, if you're working on something, you have a speaker loose, face down. Even a console, face down. Or a cardboard. But if you're working on it, you know what? Face down is all right. Because you can crack the rim around it. You know, break the glue. His trick for fixing small speakers, dryer sheets. Use dryer sheets.
After they've been in the dryer.
Right,
Yeah.
have to have you used them and stuff.
Yeah. Don't care what the color looks like. I mean, it doesn't mean anything, but other than that.
Normally white.
The main thing about a speaker is when you're fooling with a speaker, you take your fingers on it very gently and you just push to see if you can hear any resistance. If you do, that means the voice coil is either distorted or whatever it might be. Usually on the small speakers, all you can do is find another one. Okay, what else do I got? I'm wearing you guys out. This is a marvelous little instrument. This can be bought on the web. Somebody put this on. I can always have this in the wall. And if I'm working on any radio, most radios, if you have prints or anything, will say this thing draws 85 watts. So I take the variac, I run it up, 125. How many watts is it drawing? If there's something wrong in there, it'll say it's drawing 110 watts. Well, guess what? That transformer ain't gonna last too long. There's no two ways about it. 47 pilot lights. An original 47 pilot light, by the way, does have a blue bead in it. If you get the ones from Korea, I don't know what color it could be. We said tubes for test only. See that guy when you need tubes that cuts down. You know they're going to be good unless you find something new in the box, but the box better match the name of the tube. Alignment tools. Now I have hundreds of these. plastic. Short out that trimmer on that can when you're adjusting it. Bye-bye. But these are available a lot even from scrap radios. There's an input and an output, and they're different. And what we see on that sheet I show you is the bandpass, which of course I jumped around and missed that. But you'll see this first tuned circuit that you're looking at. If you would sweep this with a sweep generator, what you would see is this analog signal. Right down that center is the 455. To the right and the left of it are the sidebands. Now that's made, there's two coils in there, they're spaced apart, okay? So you go down there, you look at that, and that is actually set for the bandwidth. Because if you look at the bottom, it's called the 7.07 point. If you come down here and you look, to the left you'll see a couple kC above 455, on the right you'll see a couple kC below it. I don't have my, can't see from here, but anyway. What else is on
To
here?
the right and to the left.
But you notice that the shape changes as you get into the second IF can. This one's a little broader in the front. This is starting to shape the boundaries. This keeps the selectivity of the radio such that adjacent channels doesn't interfere. The quality of these cans will also determine that. The Emerson will be cheap, you know, it's from the scrapyard, and the other ones, an RCA or Philco is going to have a damn good IF can. There's no two ways about it. Let's see, what else we have in here? That's pretty much that. So we do see on this one sheet, if this station was coming in at 1000 on your dial, 1 megahertz, look where the oscillator is running, 1.455. Always check your IF frequency. Some of those sets in the 30s, they vary. Car radios are always 262, and they actually are more sensitive, believe it or not. Most car radios are. In fact, if you ever convert one to house current, you'll find something out. They're amazing. They really are. Okay, we said about aligning the 1400. This is a loop on the back. A loop was a cheap way to do it. Today we use permeable cores. Philco came up with a fabulous idea in '39. They came up with this console set that had these copper bars in the bottom. Well, when you have a wad of wire, think about this. You're picking everything up. All kinds of noise, all kinds of stuff. Well, the Philco had a triode front end with a small bar on it. The impedance was different. Yes, it's directional, we know that, but it doesn't pick up the noise. We've been in situations down in Kutztown where you can hardly hear anything, and we'll turn on one of the Philco sets with on and say, my God, listen to that, we're getting KYW. Christ, down in Kutztown, there's so much junk thrown through the air and the barn wiring. Forget about it, we get WAB
That's it.
and Reading, that's about it. There's so much stuff going on, security systems and whatever. It's a miracle we get him a cellar radio. But usually we tell them, here, take it outside, and you'll hear it. You pull up with your car, you'll hear it. Anyway, if you guys that don't know me, I'm Lewie, after I've yacked on your ears all night. And I don't know if I missed anything. I tried to think about it, but I think this is really an example of brilliant engineering. And you have to think about this because in these sets were designed, we're looking at 32 and 33, and people were out in the soup lines. They couldn't go out and afford a console. Maybe you lived up in, you know, upstate New York or something, you had a lot of money. A lot of those sets were farm sets because, you know, they ran off of everything. But this little table set, they dumbed it down. That was capitalism at its best. They designed parts that would work on the cheap. But you want to know something? You do these radios right and you're going to be amazed. You will be amazed what you can get out of them, some of them. Like I said, go with the brand name. Fix an RCA Bakelite. Try and fix the sets with these big cans in until you realize what's going on here. Because later on, these are air trimmers. The other cans have slugs in them. That increases the coupling between this core and that core. And believe me, they should not have to be adjusted. And if they do, there's really a problem in there, and you have to get the top and the bottom. This is really easy to do from the top. Just don't use a metal screwdriver. Same thing up here, because you actually will detune that circuit. And you can always tell which is the oscillator. Just put your finger on the one. There's no voltage up there. You'll hear it change stations. They're going up and down. And like I said, this guy, the easiest way to do it, put a loop of wire near the back of the radio, because now you have a natural coupling. Once you hook a lead to something in there, you follow what I'm trying to say? You're actually, you're changing the circuitry. The other thing, there's a couple other things. I know I'm getting along in the ear, but when you change parts, I brought this gun down. These you could pick up for peanuts. You're working on a set like that. This is what you really want to use. The reason why, this puts out fast heat, really quick, and it's a done deal. You put one of these little small ones on, you're sitting there holding that sucker on there, holding that sucker on, then you're trying to unwind its wires and they haven't lapped 3 times. Clip it off. Clip it off. Clip it off, put one turn on, put a little 32,000 solder on it, but always lead the value of the cap to your face. You'll see guys will change them. What the hell value is that? You're trying to twist it around.
Yep.
You know what I'm trying to say? You don't want to do that. Rubber wire. Tubing. The wire is bare and it's floating around in there, slap a little tubing over it, unless you want to change it. You get a Zenith with the keys on it. Oh my God, rubber wire going through that harness. If you have to do one of them, forget it. And by the way, they have the lousiest prints too. They're nothing to brag about. If you have a copier, the best thing to do is blow it up. The other thing that burns me up about them is they'll have a legend. It'll say C2 is a 005. Well, you look on the print, there's 5 C2s. You might only see the first one. So you got to take everything and write the values down on it. That takes time to do it. Okay. Solder wick or solder sucker? Now, solder wick is probably better for printed circuits, but you can use this too. The solder sucker will get the goobers off. But a lot of stuff like the Zenith, I don't think they ever had a bad solder connection their whole life. They wrap that stuff around there like that. You keep fooling around with it, you're going to break a pin off a tube socket. And you got a mess. The big solder is going to give you a glob and a short. Use the finest solder you can. Older sets, 30s. M is not meg. M is K. They finally corrected that. So if you go on there, you see this M on there. Meg is meg. That's million ohms.
Someone would say M and they'll spell out
Meg, yeah.
Yeah. If it says it's a mica cap, I doubt if you'll find mica caps in these kind of radios. But you will find also that they don't give you much trouble. This guy can. This is the oscillator coupling. This is always C3. That's always 50 picofarads. All right? And this resistor's got to be fairly close. The resistors that are in the megohms, you see on your sheet on the megohms when you're looking at your prints. The megohm resistors, you look at them, they're a little grainy. They can be very high or they can be open. So make sure they're good. You'll find one usually up in here, and you'll find one on this AVC line. This is actually the AVC filter, the C9. Don't try and shotgun a radio when you take it out of the box. That is the first mistake you'll make. You're going to be in trouble. You start here. All electronics starts from the power supply. Here you have an indication on your meter what your signals are going through. Now you tweak this. You tweak that. Then you bring your oscillator in. This can give you a problem. This C3, the coupling, 50 picofarads. Sometimes they open. This resistor has to be pretty good. This is the grid leak that's for the oscillator. I think I pretty much covered this, but look, if you take this circuit, you look at it, I have more sheets here, and you go take a look at a complex set, you will see the same thing. What they did though, remember I said this had two functions? How about they put a separate oscillator and a separate pentode up in there for the mixer? How about we put a 686 dual diode in there and just put a triode? Now you're out to 9 tubes. I got a 9-tuber. Then I put 4 audio tubes in it. I got a 13-tuber. Is that called bragging rights?
Call more money than it's sold.
Exactly right. Well, fellas, I think I tried. Oh, there was another little tool here. Boy, if you can find one of these, you got a home run. I think I showed this to you years ago, didn't I? Do you know what this is? Oh, this is beauty. I got this thing when I was 16 years old from General Cement. This is a universal control cleaner. We would put trichloroethylene in here.
Oh, yeah.
It screws right on the nut on the front, and there you go. The juice shoots right in. But the WD-40 will do it. Almost all your controls, if you look at them, there'll be some space. It's a marvelous thing. I don't care what anybody says. It's gooey, sticky, or whatever. Here's the other thing, old man.
I don't need that yet.
Well, let me tell you something. You could really see a lot. Here's another little gimmick. Here's a little hook. You can grab a whole little picks or something like that. You know, it can work good. You know what? One of the problems we had on the Z Bomber was uses Loctile tubes, and of course they're 1.5 volt filaments. You should see the way they're in there in the sockets. Well, a lot of times these Loctile tubes, they lock in. And I found out who made them. The locks are different. Some are thicker than others. Trying to pull these things out and get them back in again. What happens if you look at those little pins that are down on there? You should really polish those pins very good. And also look at the pinhole. Because from wiggling this thing around, you want to get an intermittent. They are a pain in the butt. But anyway, I hope sometime in the future, there's a lot of talent in this room. I don't have to be the person that has to present these things. But I promised to do this about 7 or 8 years ago, and it hadn't been done, so I figured, let's do it while I'm still vertical. So.